Hi everyone. Let's say we are given a circular coil of, let's say, radius 5 centimeters and placed in a magnetic field, a uniform magnetic field in direction, making an angle, let's say, 30 degrees with the plane. That's the magnetic field B. Let's say also that we have given B is increasing at a rate of 5 millitesla per second. The question is, we need to find the induced voltage in the coil. And let's say that this coil has a certain resistance, R, it's a wire, and the resistance of this coil is 100 ohms. So we need to find the direction and value of the induced current in the coil. So we use Faraday's law. According to Faraday's law, the induced EMF, it is minus change of the flux with respect to time, the magnetic flux. So we have minus, the area is not changing. Basically what's changing is the magnetic field, dB by dt. And the angle between B and the normal, if we draw the normal here, the angle between B and the normal, that's the normal, is 60 degrees. So it will be cosine of 60. Keep in mind that the flux is BA cosine of theta. So since B is only changing, it becomes minus area times dB by dt times cosine 60. And we solve now for E. So the induced EMF will be the area of a circle, it's pi r squared, dB by dt. And we have cosine 60, which is same as sine 30, which is half. So I'm going to keep it now cosine 60, and then I'll substitute. So it becomes minus pi. The radius is 5 centimeters, so it becomes 5 times 10 negative 2 squared. dB by dt, it is positive since it's increasing, so it's 5 times 10 negative 3 Tesla per second. And cosine 60, which is half, so I'm going to keep it cosine 60. And we solve for the EMF using the calculator. Let's see what we will get. We have pi multiplied by 5 times 10 negative 2 squared multiplied by 5 times 10 negative 3 multiplied by cosine of 60, and we will get 1.96, which is around 2. So around 2 times 10 negative 5 volts. 2 times 10 negative 5 volts minus. The minus sign here means that the voltage or current is clockwise. So it means that it is clockwise. Then I, the current, will be, according to Ohm's law, E over R, which is minus 2 times 10 negative 5 divided by the resistance, which is 100 ohms or 10 power 2. And the answer will be minus 2 times 10 negative 7 amperes. Or we write, or 2 times 10 negative 7 amperes, and the direction is clockwise. Direction is clockwise. Another way of determining the direction of the current in the coil is using the following technique. So B is increasing. So according to Lenz's law, if B is increasing, then B induced should be in the opposite direction of B. B induced is in the opposite direction. Since the direction here of B is upwards, So B induced should be downwards. B induced should be downwards, is downwards. And by using the right hand rule, if B induced is downwards, then the current I induced will be clockwise. Okay, because downwards, clockwise means negative. To the left also means negative. And this is another way of finding the direction of I induced, which is clockwise. Thank you for watching.